much everybody for coming, and a big welcome to Ben from Satalia, Ben Calnan. Ben's going to be talking today. So Ben's a product owner for Satalia. We were having a chat earlier, and I know that there's a bit of machine learning involved in not just this product, but a lot of Satalia's products. So I did ask Ben, are you a machine learning expert? And he said, no, I'm not a machine learning expert. My background is actually in geospatial data and manipulation, which sounds really cool as well. So it's a shame we can't talk about that in this time. But Ben, as I say, as a product owner, he works on a product called Satalia Field Service, which is a new product, I think. So,
that's right, yeah.
Yeah, Ben's going to tell us about real-time scheduling and machine learning using Satalia Field Service. So thanks very much for coming, Ben, and take it away, please.
Thanks, James. Thanks for having us, guys, and it's great to see so many on the call, so really appreciate that. Yeah, my name's Ben. I'm a product owner. I've been with Satalia now for about 5 years. Before that, I worked as a consultant in telecoms and also as a developer with a sort of geospatial background, most of those sort of roles. I've also got Panos here, who's one of our sort of senior optimizers, who's working on this project, and Jonas, who's one of our best developers as well. So if there's any sort of technical questions around development or optimization, then I'm sure they'll be able to help as well with that. So yeah, Field Service is a product that's in development at the moment. We're sort of midway through development, and I thought it'd be really cool to just tell you a little bit more about our vision, really, for the product, what it does, what it's going to do, some of the sort of industries we're looking at sort of working with, and as well as some of the sort of side projects. We also have a kind of spin-off side project from this that we're working with the UK government on as well. So, and then finally, we've got a demo as well, which we can sort of give you an update of as to where we've got to with this, and maybe it gives you a bit more of a visual understanding about how the system works. Okay, brilliant. So Satalia, just for those who don't know, I imagine most of you have already come across Satalia, but for those who don't know, we're a company that has sort of spun out of UCL over 10 years ago, about 100 people now. Our sort of main bread and butter, I suppose, is optimization. And by optimization, it's around sort of optimizing resources to try and maximize some kind of KPI or hit some kind of KPI. So that might be reducing travel time, it might be maximizing the use of employees, it might be a whole range of sort of these sort of constraints and goals. But that's our sort of bread and butter. We also we have a strong pedigree now in machine learning. So we do a couple of things there. We sort of build bespoke models for some of our customers. We go in and sort of work with them on their data side. And then we also do AI strategy, and Daniel, our CEO, and a couple of others will go and work with other leaders about their strategic objectives when it comes to sort of artificial intelligence. But as I say, optimization is our kind of core work, I suppose, and where we've worked with Codurance before, I suppose, is around building some of these optimization systems for large organizations. So typically the optimization engine will be built specifically for their goals to kind of solve one of their business problems. And you know, the types of problems that you get that are probably most familiar are the sort of ones around the last mile delivery side things. So we've worked with Tesco, that's quite public knowledge. We've worked with DFS, and we've worked with Woolworths in that space around sort of optimizing vehicle routing when you click your slots. And then on the other side, we've worked with sort of professional services companies such as PwC around optimizing their staff. So those are the kind of some of the big companies we work with. And when we try and work with these companies, what we always do is trying to bring back the knowledge we've learned and some of the sort of algorithms that we've employed there, and build them into a kind of generalized product. And the aim is ultimately to build a product that will do solve all of these business problems for each of our customers. And they're quite repeatable, but they usually have a sort of bespoke nature for each client. So what we're trying to do is build, as we go along with these different clients, build these constraints back into a kind of generalized product. So every time we go to the next client, then we have less sort of customization to do, really. And these sort of two products, I suppose, fall under two kind of areas. One, we have this workforce product, and this is what we do for the professional services. This is very much around a static optimization sort of problem, where you know all your resources, you know all your staff, you know what jobs you want them to carry out more or less for the next, say, 6 months, and bung it into an optimization engine, and it goes off and runs for several hours or days even, and it comes out with a very nuanced schedule. And that's really good for those sort of companies which have these large number of constraints they want to capture. So things like, client satisfaction or maximizing utilization, and all these employees will have different skills and all this sort of stuff. At the other end, we have the sort of delivery side of things, and that's very much a dynamic system. So when you have, you're picking your slots, what actually happens is 2 weeks before that particular day where the delivery is going to be made for your supermarket delivery, a schedule where the slots are open, there is an empty schedule that's sitting within our system. Over time, the slots come in, our customers will pick a particular slot and the schedule gets built up. And in the background, there's an optimization agent as well that's running. It's trying to squash out as much of that unused travel time, reduce the travel time, open up more slots, improve the efficiency as much as you possibly can until the night before, when the delivery gets made, about midnight or 11 o'clock, the supermarket will shut off the slots. And that gives the pickers time to then go out and pick what they need to pick, and pack the vehicle ready for delivery the following morning. So that why I'm telling you about this is Field Service sort of takes both of these products and it sits somewhere in the middle of them, really, because what we want to do with Field Service is provide a plan for our clients, so maybe 2 or 3 weeks out, a static plan that captures some of the constraints that their client may have. So, but also allow that dynamism that you get in the last mile. So things might change leading up to that particular day. For instance, a staff might go sick, there might be new tasks that come in, and even when you get to sort of the same day, there might be some emergency tasks that need to be carried out. So it's a lot more, in some ways it's a lot more complex, because we're trying to capture the huge number of constraints that you might have with a kind of static optimization, with the performance and dynamism you get with a dynamic schedule system. So yeah, just to summarize it then, what is it actually used for? Well, Satalia Field Service is about assigning people to the right tasks, either planned dynamically or in an emergency, and that's obviously different to vehicle, a delivery, which is all about delivering products. And the reason I suppose it's so different is that people have multiple skills and there are multiple constraints that apply to this particular problem. And there's also this question about, what do you do when things change on the day or leading up to that particular day? So that's why it's a product in progress. We're sort of about halfway through. We have the static side done more or less, and we're now moving into building the dynamic and the live side, which I'll tell you a little bit more about shortly. But the vision is really to build like a SaaS tool that's available for a whole range of different industries. We've identified that there's like several different areas that this is kind of a product that would be useful for. Unlike maybe last mile delivery, where you have a limited number of large supermarkets willing to invest in a product like that. There's obviously there's a global issue, but there's only a limited number of supermarkets. In this sort of field service world, there's plenty of different industries where assigning people to tasks is a core part of their business. So, for instance, we work with some large telecoms company, that's obviously one of them, but there's also other areas such as council services, healthcare, property portfolios. So there's a wide range, and what we're trying to do is generalize the problem within the solver, and invest potentially in a very flexible UI that allows you to sort of configure it as you like. So I guess what sets us apart from other companies, why us and why not use some of the scheduling systems that are already out there? Well, typically in we've come across a lot of these companies, they will have a very large embedded CRM system or existing system, and scheduling will be a module that's bolted on, really, that's available as an add-on. And it's not, we're a specialist in optimization, that's what our core business. So what we think is we come a bit from the other end. We'll build something that's bespoke, or something that captures enough of the constraints to act as though it's bespoke. And we'll do the best we very much can in the optimization. Then we'll integrate with any systems that they may already have within the enterprise, whether that's Microsoft Dynamics or Oracle or some other system. And ultimately, the other part of the vision is, why is this of benefit to people? Well, it increases efficiency ultimately, and it increases the automation you can for processes. What we've noticed in a lot of these organizations is scheduling is still done by hand, or at least it's done in Excel or something like that. And as you probably know, as the sort of size of the problem gets larger and larger, this becomes exponentially more difficult, both for humans and computers. And humans really sort of struggle after, 20, 30 different tasks, engineers or operatives. Computers also struggle, so that's why you have to employ very complex algorithms and fancy algorithms, and why we have optimizers working at the company. So yeah, but once you've built that and you can automate a number of your processes, you're making savings both in the optimization of your schedule, or however you want to optimize it, but also the people that would normally be doing this scheduling manually or through Excel or something are freed up to do something with their time. A lot of these people are very highly qualified and they're actually just bogged down in scheduling, so it's kind of cool for them to be able to be released from that and go off and actually do what they're qualified to do. So as I mentioned, there's a few different industries here that we're looking at. Obviously, telcos and utilities is a big one because we've done some work in that before, and it's obviously proved its worth. Large property management firms and housing associations have a very similar problem. They have they obviously maintain a large number of properties, and they have engineers in-house and contractors that will go around and they will go and fix these properties or maintain them, such as, if there's a leak or a boiler, some kind of boiler problem, and a lot of that needs to be scheduled, but also a lot of it has to be reactive as well. There's the public services stuff I alluded to. So this is not always exactly the same problem, but we believe our system could probably accommodate some of the issues that some of the council services that provide sort of scheduled plus dynamics, scheduled plus dynamic problems. So things like providing services for picking up people that need to visit hospital because they can't get there themselves, or home to X as it's known. So the councils often have to effectively pay for taxis to pick people up and take them to places because they haven't got the schedule. They haven't managed to organise a kind of a system for scheduling some kind of service to pick these people up and take them where they need to be. So there's definitely opportunities there. The final one is healthcare, and this is interesting because we've actually got some kind of spin-off project, which I'll tell you a little bit more about later, with the UK government, and this is around in the NHS and in some of the sort of social care services that surround that, provided by the council. They have a huge problem with scheduling of staff, particularly around visits to home, where there's both domiciliary care, which is around people that go and visit people to help clean or carry out tasks that they're unable to do. And those are typically run by private companies under contract to local authorities or sometimes to healthcare trusts. But then there's also nurses, and these are obviously qualified health professionals, and they carry out visits at people's homes. And it's an interesting problem because they have some very nuanced constraints, but it's also at the moment a huge bottleneck for the NHS because they spend an inordinate amount of time manually scheduling people. And in fact, nurses are doing it themselves when they could be freed up to actually do other work. So it's quite pertinent. There's been an announcement by the Ministry of Health recently that this is going to be an area to focus on. So yeah, we've got a spin-off sort of project which I'll tell you a bit more about shortly. So just about optimization, our system's made up of, I guess, two or three core services. Optimization is clearly the core of it. We use a number of different algorithms. Primarily, we're focused on meta-heuristics, which is, and Panos on this call is a specialist in that area, which allows us to scale to very large problems and be able to perform optimization across very high performant nature. The scheduling is notoriously difficult to solve as it gets bigger and bigger, and computers really struggle as well. So if you don't employ these kind of algorithms, you could be there sitting there for literally years, decades for a result to come back to you. So you have to be smart about it. Field service in itself has some particularly interesting constraints, I suppose, that maybe you wouldn't have in other scheduling problems. So it's by nature, it's multi-period. So you would have often to visit the same place multiple times during a particular horizon. There are things such as that often come up, such as synchronization of engineers or staff, where two people have to be on site at the same time, or even a precedence where one staff has to do something before another person has to do something else. One other interesting point is in the healthcare world, there's this continuity constraints. So quite often patients want to see the same person again and again. They don't want to be handed between staff members every week. So the solver has to kind of keep track of this kind of who has seen this person before, and try and make sure that they see them again for the future visits. As I mentioned, so requests will be static potentially, but they also might be dynamic. And I'll just try and talk you through a little bit more of that now on the next slide. So what we want to be able to do effectively is allow, because companies work and organizations work in different ways. So some companies are more than happy just to you know, run a schedule on a Sunday night for the following week, and that's it. That's fine. That already does more than they, you know, than they've got at that particular point, and that's the planned. And you'd run that maybe every Sunday for the following week, the whole week. For instance, we have a client who works in the coffee industry, and that's how they work, and they plan over the next 2 weeks about who people need to go and refill these coffee machines at people's offices. The dynamic part is the slots. So effectively the schedule can be changed leading up to a particular point in time. And what that opens up is the ability for either some kind of operator to go in and add and remove staff, or add and remove tasks as needs be if they come in via phone. Alternatively, you could be client driven, and you can have the slots like you would have at Tesco or Sainsbury's, and that will build the schedule from that side. The final sort of part to it is the live part, and this is where it gets really interesting from our side. I guess probably most people think of live scheduling, they might think of Uber or Deliveroo, and that's a slightly different problem to what we've got here. So Uber and Deliveroo, effectively you have drivers milling around. The algorithm will be looking for those free people who are free in that particular area, and it will sort of offer out that job to a particular person, and if they accept it, and they will go off and do it, and they'll be out of action until they come back online. What we're trying to do is, I suppose, we've already got a schedule for that particular day. The person already has that schedule. It's not ideal to jiggle it around, but if it comes to it, that might have to happen. So that there might be the case that a new task comes in, an emergency, someone's fallen down the stairs, or next boilers, there's a big problem with the boiler or something like that, and the schedule will have to decide A, whether it can accept that task, and B, then if it does accept the task, does it have to move jobs around or even kick jobs off the schedule, that person's particular schedule. So it's quite an interesting sort of problem, quite challenging problem. And it also requires a kind of end-to-end system. You effectively need a mobile app, you need to understand where they are, so the optimizer can sort of do the travel time calculations. You need to be able to feed back any of those changes. It also unlocks some other interesting stuff, like you can start using live data as well. So things like traffic information can be pulled in at that particular point. And when you do that, then the optimizer can start looking at, well, is that person actually going to make to that particular appointment on time? If not, can we move it between staff? And as you know, you can move, you do have that freedom to move jobs between staff, providing they match the constraints, unlike with a vehicle when you're delivering products, because the products are on the van, they're stuck on the van. So you have that freedom to do that. So those are the three types of optimization, and that's what the solvers, we've done the static side, we're working on the dynamic, and the live will hopefully sort of do by the summer. That's one of the sort of free services. The other is the routing sort of engine. I suppose this is close to my heart, as I have a background in geospatial. But so routing, what effectively it is it's another service that the solver consumes, and it's effectively a cost engine. So one of the sort of costs that the optimizer is trying to reduce, usually but not always, is travel time. So it wants to reduce the number of time people are on the road, because obviously that's wasted time to some extent, time that could be used to be carrying out other tasks. So the routing engine we've historically used has been OpenStreetMap routing machine, which is awesome. It's an awesome product. It's built specifically to run on OpenStreetMap data. But over time, it's kind of we've found it's caused some bottlenecks in some of the performance of our solvers, because the solver really has, in some cases, very limited time to run, and it all adds up. So we've gone away and we've built a Rust-based system. Our routing team has, and it's absolutely blazing fast. High performance. It does three things really. It can consume multiple types of data. So we can use OpenStreetMap data, which is really useful maybe in a SaaS product. where you don't want to necessarily be offering commercial data to those users. It's able to consume commercial data as well, which is also useful. I'll tell you about that why shortly in a minute. It's very, very fast, so it's a lot faster than OSRM in terms of returning some response times. And as I mentioned, the slots in particular, there's something like they have a 200 millisecond, usually the SLA is around that, and you have to show these slots within 200 milliseconds. So the solver's got to do a ton of calculations, and routing's only one of the very small parts of that. So reducing that time down is crucial. And then finally, it's able to consume a large number of combinations of points and addresses in a single request. If you think like sort of Google and here, they're able to provide sort of these square matrices, which effectively is travel time costs between points, which is what the optimizer needs. The maximum they can do is 20 to 30. We're talking about thousands here, so it's a huge uplift for the solver, and it allows us to sort of solve much larger problems much more quickly as well. I mentioned that there's different types of data. So one of our partners is actually here, and we use them for a lot of our clients. And the reason we do that is because the quality of data is uniformly good across the whole country, across the globe actually, but also they have a lot of restrictions. They capture a lot of restrictions that aren't necessarily captured in OpenStreetMap data, at least not yet. So particularly useful around things like trucks, where there might be multiple restrictions affecting which roads they can go down at different times of day, whether they're allowed to use turn left or right at certain times, etc. And you don't want to be sending them down these little roads if that's not the reality. So that information is captured in this here data, and we can consume that in the routing engine and then generate the travel matrices for the solver more accurately. So that's the routing side of things, and that's another service that sits within the sort of platform. The final part is the machine learning part. So machine learning is interesting actually, because we don't have a generalized platform that sort of feeds into the system yet. The reason we don't do that is because we found that often a lot of these companies the problems the data, the way they store their data, and the format of the data and the quality of data is very much specific to that particular company. So often you have to build quite specific models to be able to consume that or integrate with them. We obviously have some generalized components that we can reuse, but typically that's what we have to do. We have to go in, understand how their data is stored, how we're going to extract that data and integrate with that system before we can use it. But what it does do is, once you have these models, it can provide a very powerful way to help the optimization engine make better decisions effectively. It can sort of signpost what those decisions should be, what kind of decisions it should be making, or it can be useful in giving it better information. So I suppose two kind of areas where this is often used. One is around predicting the length of time a task will take to complete. So obviously you can say, well, it's a certain type of visit, is that carrying out some kind of boiler repair, it's going to give them an hour. But the reality might be a lot different to that, and there might be a load of different reasons why that is. So for instance, it might be specific to the engineer carrying out a particular task. It might be the time of day. It might be if they've been working all day and they're tired. It might be they don't have the tools or something like that. So these sort of models are often really useful for predicting that information. And there's a feedback loop there as well you can use from the app, because the app has that location information. If you capture that location information, you can infer how long a task takes, and you can feed it back into the model. So you can sort of have this self-learning kind of feedback loop, which is super cool. The other area that's that actually provides a lot of value, and sometimes it provides the most value actually, is around understanding what reasons a task is most likely to succeed or to fail. So that might be because when tasks fail, or they require a follow-on visit, as they're sometimes called, that becomes very expensive for a company, particularly if they're working with contractors. So yeah, some of those sort of understanding which features are indicative of a task that's likely to fail, then you can then sort of tweak the optimization engine to sort of avoid some of those sort of those particular sort of decisions. So maybe it's, as I say, maybe it's a particular engineer in a particular geography, or in a particular time of day, a particular type of task in a particular time of day. There's a whole range of different combinations there, but that sort of feedback loop is super powerful, and it's quite a good way of saving money for a company. And just leading on to that, I just this is a company we work for, an organisation we work for, a very large network provider, or infrastructure broadband. You might be able to guess who they are, but they already had an incumbent scheduling system. But so the savings there weren't necessarily that huge, but the savings from some of the data science models on the right-hand side there, and that was around sort of predicting whether tasks were going to succeed or fail and why that was happening were quite significant for them. And that was only a very small subset of their business. So definitely worth looking at if that's possible. So yeah, that's the vision. And just to talk a little bit about the architecture actually before I go into this Innovate UK part of it. The system's built, we tried to build it sort of, it's a cloud-based SaaS system. So we've tried to make it serverless where possible, scalable. So we're trying to take that sort of weight off our shoulders to some extent. The solver's run in Kubernetes or a derivative of that, some kind of, I think we use the AI platform in Google Cloud Platform to run the batch processes. All the APIs are running Cloud Functions, so they're all serverless. The aim is to deploy this via a single multi-instance version, but obviously the reality might be that we have to deploy specific customer instances on their own hardware. So we try to make it relatively portable as well if needs be. Okay, so just before, I've got a sort of demo I'm going to do in a bit, but before we get there, a little about this Innovate project. So last summer we applied for some funding as well to kind of push this project along, and the spin was around bringing in technology around these other, what we've done for sort of other industries, and seeing if they could apply in the healthcare world, specifically scheduling of nurses actually. So we're partnering with University College London, Care City, who are a kind of accelerator for bringing new technology into health, and North East London Hospital Trust, who are going to be helped sort of with some of the testing and feedback. So it's not a particularly large amount of money, it's about 400,000, but it's over a 9-month period, and it's sort of really helped us gain exposure to some of these sort of end users that might be using it. So that's been great. It also has a sort of COVID spin. It had to have a COVID spin in the application, and the way what we're talking about here is we're trying to minimise infection chains as well. So minimise the exposure of staff to patients. So it's to do with that continuity of care. If you can reduce that, improve the continuity of care, you're less likely to a staff member to be seeing all sorts of different people, and obviously then you're reducing the infection chain. As I mentioned, yeah, we've got UCL and Care City on board, and Care City in particular have great links in to some of these organisations and have been really instrumental for us. So we are halfway through the process. We've obviously engaged with some of these organisations, and we're now doing workshops and starting to prototype based on some of that feedback. When I talk prototype, we're really talking about the constraints, because the solver's already there, and the architecture's there. We're talking about the constraints and then some of the UI as well. So yeah, it's an exciting project, and hopefully by the end of it we'll have something that will be useful for in this particular realm. So yeah, before I get to the demo, the current solution, as I say, it's a SaaS solution, it's a managed solution, it's pretty scalable. We can schedule a large number of engineers. It's multi-tenanted, so people can sign in with a sort of organisation, and it has all the kind of SaaS stuff around it, around subscriptions and role-based access and whatnot. The optimization engine can consider some of these factors, such as skills, or all of these factors, time windows, so that's when they should be arriving or departing, constituting staff, preferred providers, so that is whether the organisation is in-house or contractors. This comes out of some of the work we did for the large network provider, because they provide a lot of their services via contractors, and they had to give us X number of tasks to each of these contractors by, they've contracted to do that. So that's something that we'll probably develop further should we need to. We have this sort of concept of regions. So in a last mile world, a supermarket world, everything's tied to depots, because the vehicles start and end there, the produce is picked there, and what you get to see and when you log in is actually decided by what stock that particular supermarket in your area has. Obviously, in our case, we don't really have that concept. So people start and end at their own home, and they will have a region, but it's usually a bit fuzzy. So we have this concept of hierarchy. So where we'll try and find, engineers that are working in a neighborhood. They can't find someone in a neighborhood, they'll look for engineers that sort of work roaming across a higher area. It's kind of useful, and that's the way these sort of network providers tend to work, actually. We have the concept of priority, which the solver will try and schedule high priority jobs first before low priority jobs. That will become important when we do the live stuff, because obviously the high priority jobs will potentially kick off the low priority jobs out of the schedule. We have the duration of the task. We have the concept of multi-visits. So, you have to carry out several tasks to complete the overall parent task. Service gaps is another sort of constraint that the solver, and that's what that means in this particular case, is there has to be a particular number of days in between the multi-visit. So going back to the sort of the coffee example, they are contracted to maybe visit a particular site twice every 2 weeks, but there has to be at least 4 days in between that visit. Otherwise the coffee machine will still be full. It's pointless for them to go back. So it's kind of trying to model that behavior. And then you've got all the stuff around the actual staff members' sort of availability, so their shift start and end times, how long they are allowed to work without taking a break, or what's the minimum amount of time they should work before they take a break, how long they must drive, how long they're allowed to drive before they have to take a break, the number of breaks, etc. So there's plenty of things there. The roadmap, though, as I say, we've done the static part of it. The dynamic part is sort of in development right now, and that's basically the slot picking. The mobile app is in the App Store, so you can actually view schedules, and it's all sort of subscription based, so live events. So if the schedule updates, the app is automatically updated, and the app can also feed back status updates, such as I'm en route, or I've completed the job, and that goes back into the main operator UI as well. There's a two-way relationship there. And then finally, in the summer, we'll be having the real-time scheduling. So I suppose that's the nitty-gritty of the development work, the hard work. So Jonas and Panos will enjoy that part of it. But that's pretty much the overview of the product. I don't know if anyone wants to ask any questions now, or whether you want me to go on and do a demo. Is that?
Yeah, I've got a question from what we've heard so far, Ben. By the way, if anybody else wants to ask a question, just stick it in the chat window and I'll pass it on. I've got a kind of philosophical question, because it feels like when we're talking about optimization problems, we've got some kind of cost function which we're trying to optimize, whatever that cost function is. And there are a lot of constraints and there are a lot of resources. I'm sure I'm not using the correct language in terms
That's right, yeah.
Are laid out. In particular, because you mentioned the NHS and how those NHS resources are deployed. And I wonder if anybody in Satalia has heard of a company in the Netherlands called Buurtzorg, and they do district nursing care. And their company basically grew up because one of the things that they'd noticed, the founder of the company, I think, worked in nursing himself, and realized that because things were being over-optimized and there was this big business involved in district nursing, what they were doing was they were being encouraged by the systems, by the cost optimization mainly, to take less and less time with appointments, and they lost that personal touch. And they twisted it round, and what they've ended up with is a model where they don't allow any organizational unit of their nurses to grow beyond 12. Now, and what that means is that effectively what they've optimized for is directly for customer care. Now, I'm sure they didn't use a tool such as this, but I wonder, with this type of idea, with this type of optimization model, could it be something that one could plug into a model like this to actually get the model to understand and reconsider what the constraints are? Because it seems to me that that's kind of twisting it on its head and saying, what might this model look like? If, for example, I put into this thing, I've got a pool of 200 nurses, but I want to optimize for care. Could I twist that around and say, well, don't use that as a constraint, but use that as an output, and give me some business insights on what it might look like if I was to reorganize my business and therefore reorganize those constraints. Did that make sense?
Yeah, I mean, totally. So the optimization is completely configurable. I mean, we talk about efficiency, but that's not the only the driver for many of these services. So you're totally right that, in the NHS, quality of care is something that you probably want to factor in. How you measure that is probably an interesting topic in itself.
That's what it comes down to. It comes down to measuring that. I mean, in my terms, as I know from optimization and annealing, we talk about a Hamiltonian energy function. Is it all about defining that energy function in a way that best matches the exact problem that we're trying to solve?
Yeah, I think so. I mean, it's interesting you mentioned about sort of that, because one of the customers I think you probably work with as well, DFS, they have that. One of the things they came up with was, they understood was that some of their drivers, when they went to some of these people's houses and they spent more time with their customers, particularly if they're first-time customers, the actual the follow-on business they got from those customers were a lot higher, because they had a better relationship with, a better understanding of DFS, a better relationship with them, so a better experience with them. So it's not always just about sort of reducing down, getting as many people jobs in as possible too.
Okay. Thanks for that. We've got a question from the floor. Akbar asks, for the predictive aspects, e.g. predicting length of task from its features, what part does confidence intervals and uncertainty play in the model?
It's a very good question.
Sorry, Akbar, just unmute yourself if you want to continue the dialogue with Ben. But go on, Ben.
Yeah, just very briefly to tack onto that. So I'm aware that with a lot of these kind of predictive sort of tasks, you've usually got a degree of confidence associated with either classification or a particular regression. And I was just wondering if the threshold, if there's anything like a sort of a threshold of confidence that you use in the model, and if so, if that plays a part, is this something that forms a part of like an informed discussion with your clients? So you sort of say, what's the threshold that you would like to set, and we can help advise and inform you? Or is it something where you're using, I don't know, sort of industry heuristics for this sort of thing?
No, it's the former. So we tend to work with the clients, and there's usually an education piece there as well. Some of our data science will work with some of their scientists, and they'll agree on what confidence intervals they're willing to accept when working with this. I mean, there is a sort of a leap of faith to some extent that you have to take with some of this stuff, especially working with optimization. So if you're using data science models to inform decision making in a live environment, that's kind of a little bit scary sometimes. So you have to be very clear about what confidence intervals are willing to accept, and really work with the client on that, I think.
Okay, thanks, Ben. Okay, any more questions at the moment, or should we have a look at the product? Okay, no one's putting anything in the chat window, so on you go, Ben. Thanks.
Sure. So I'll give you a pretty brief demo. We've got all the sort of SaaS stuff here. You've got the the account, the organization, users, roles. You can set your app user as well here if you want to for app users to see certain schedules. Got subscription stuff as well if you want to go if you use that route. It's worth noting that the UI actually it's only one route actually to use this. So typically we build the solver and the routing engine, and it will integrate with some other UI, but it's quite useful to have a UI just to sort of demonstrate what it does really, and maybe visualize some of what's going on, and might be an entry point for a customer if they don't want to invest in their own integration system. This down side, we've got the resources that you set up. So I suppose all of this terminology is configurable, by the way, so it says engineers there, but you can call it whatever you want. I suppose the most important two resources are your people and your tasks. So this is your sort of engineer or whoever the person might be. You've got your preferences around, the organization they work for, the region they work for, the skills that they have, and the shift times that they sort of are working for, as well as their start and end location. So that can be anywhere. Then the tasks, or the visits as I call them here. So this is the other really important, I suppose, resource that the solver needs to understand. The most important one really is probably the latitude and longitude, so where the task is, but also the regions. So it will match region, it will try and do this hierarchy of regions really when it comes to matching engineers to staff, to tasks. You have the duration of the task, the number of people required, the skills that they will have, the priority level, and we have the visit type, which is kind of a way of capturing all this information as a single task, because often organizations will have they will classify their work by tasks, and it will have a different types of duration skill set for each of these tasks. And often that's a good entry point for some of these data science models, actually. And then you have the preferences around the organization and the preferred person. And then finally you have, this is in a static world, by the way. So in a dynamic world, you just have the slot booker here, but in a static world, you would probably have something like this. So you have the time windows that you can potentially, the optimizer can pick from, the number of visits that needs to be required to carry out the whole task, and the maximum number of different employees that can carry out these multi-visits. So if you want to keep that continuity of care, that's another way of doing it. And the minimum days between each visit, that's to do with the service gap thing I was mentioning earlier. Then you have the organizational setup, and as I sort of talked about, that some of these organizations will carry out some of their tasks in-house, some contractors. At the moment, they don't do much in this system. They just sort of a preference, really, but ultimately what we want to do is sort of allow a much more a new configurable and nuanced sort of way of assigning tasks to organizations. So you might have a target for each of these contractors that you want to give per week or per month, and some rules for certain types of tasks to be given to contractors. So that's where we sort of envision that would go. The skills, these are literally just sort of for matching staff. So staff have to have these skills to carry out these certain tasks and vice versa. Visit types, as I mentioned, are sort of a collection of all these different things that you can sort of assign to a task, and it's kind of a shortcut, but also it might be a way of sort of classifying different types of tasks for an organization. And then hubs or depots, again, in this particular case, they don't do a whole lot other than provide the latitude and longitude for the engineer start or endpoint. But we are actively building in the concept of tools, which is something that comes up, and it's about resources. So for instance, someone might have a number of, I don't know, boiler parts or something in the back of their vehicle, and they will obviously run out at some point, and these resources will be stored at these particular depots, and they'll have to go back and pick up more if they want to continue work. So the solver will have to consider that in its processing. Regions, as I mentioned, and as a way of sort of controlling where engineers are working and the tasks that they're allowed to carry out. Shift patterns, are these just a way of sort of capturing working rules and assigning those, and an engineer have multiple shift patterns depending on the date or the time of day, the day of the week, etc. Once you've sort of done that, then in the static world, you've got, I'm just going to move this out of the way, you have effectively, you have a very sort of simple batch process solution. So you go off, you choose your region, you choose how long you want the solver to run, obviously longer the better, but it doesn't have to be the horizon, the target date, and the heuristic, the algorithm you want to use. So we've got a couple here, heuristic and a mathematical integral programming model. But potentially you could plug in any type of solver there, as it's relatively sort of they're not connected in that sense. The front end and the back end are sort of relatively separate processes. You can run it in a live mode or a simulated mode, which allows you to kind of basically play around with the data, take a copy from the data and play around with it and adjust it, and then you get sort of schedules that don't affect the overall master plan. But if you put it inside live mode, then that will affect the master plan, and it goes off, and it'll then go and run for however long you send it. What you get back at the ultimately at the end of that is some schedules. So for today, I've got a couple of schedules in here. So for the two engineers, we'll put in there, and you should be able to see the routes as well that they have provided, and you can dive in and have a look at the schedule itself, and so, you can click through and see and download this as a CSV or as a JSON file. But most likely, most organizations will use something like this via the APIs, not necessarily via the UI itself. So most of these sort of functions are available by the APIs, and they will be going forward. So it's relatively simple actually, but there's quite a lot going on in the background. But that's pretty much the demo and where we've got to far, and I hope that's of use to you and enjoyable.
There you go. Got to take myself off mute there. Thanks for that, Ben.
No worries.
Does anybody have some questions for Ben? Because I know I wanted to ask a technical question, but I'm conscious that I've already asked one of 50.
If any optimization questions here, we've also got Panos and Jonas here as well. So
I think from what we just saw there, Ben, the optimization engine, the thing that solves, that's obviously decoupled from the application, right? So
that's right. Yeah, that's right.
So if there's nobody else is piping up, I've got a question around that, because we had a look at last mile, perhaps 6 months or maybe longer ago than that, last year sometime anyway. And at the time I asked a question about whether Satalia was investigating using quantum algorithms or quantum computing in any of these optimization things. Since then, of course, Microsoft has actually got the Azure Quantum is live, although it's, as far as I can tell, it's not a particularly functional machine. But I do know that a lot of large corporations in the insurance world are already starting to use or at least investigate quantum algorithms for sort of actuarial work, which feels similar to, you know, this sort of whole class of optimization problems. So I don't know if you're the best man to answer, Ben, but some of the other people on the call, perhaps, just is this something that Satalia is starting to look at yet?
Yeah, I probably something for Panos there. I mean, quantum, obviously, quantum, the massively the parallelism you get from quantum will make some of these algorithms obsolete to some extent. But I don't know, Panos, if you've had any thoughts on quantum and gone in that route.
Myself, I'm not expert on this, so I don't. I know only some very basic stuff. But indeed, last 5 months, we have a group of people in Satalia that they are looking in solutions that they will be based on quantum computing. So this is something that we look at, and we are very interested in also moving into this direction. Obviously, here for this particular product, nothing fancy like this. Mm-hmm. But what you are describing, it is a very good point. And indeed, in Satalia, we have a group of people that they are looking into this. Not for this specific application or for this specific optimization problem, but more in terms of understanding what are the capabilities and building up the skills in the team to be able also to support developments towards this.
Brilliant. Okay, well, in that case, we won't spend too much more time on this now, but I will talk to Natalie about if there's a possibility of getting somebody from Satalia to come and talk to us about, you know, what the research in quantum computers has been and where it might go, because I'm sure that'll be a fascinating subject for all of us. Okay. Does anybody else have any questions or observations? Are you going to say something there? Oh, go on, Natalie. Yeah.
I had a couple of questions just from a kind of more sort of user perspective. So I was just interested to know about the reporting side. Does this tool provide kind of reporting so you can kind of see trends and work out, you know, how sort of optimized this, you know, your schedules have been, and you can kind of look at where you can improve?
So the optimizer does provide some KPIs as part of the solution, yeah. So and the data is exported into BigQuery as well, so it should be able to query it, but we haven't sort of built a kind of front end for that yet.
Cool. And I was also, which is not necessarily, and it might be just my ignorance, but I imagine a lot of healthcare community workers are going off into very, very rural areas which have very bad internet access potentially. So I was kind of curious to know, how does this system work when, you know, maybe healthcare workers or any field service workers have, you know, difficulty accessing the internet in certain parts of the country?
Yeah, I mean, that's a good point. I mean, obviously the schedule's downloaded over, you know, it will be downloaded as soon as they open an app, but any updates will be, you know, they may not get them until they sign on again, or they have a telecommunications access again. So it's a good point, and I imagine that if that happens, then they'll have to resort to maybe more traditional methods, such as you know, trying to call them if that's possible.
Great, thank you.
That's an interesting problem, actually, because I remember in an entirely separate context in my previous role, there was an interesting stat that came around in a talk that I saw, which was something like the number of people that have access to the internet at that time was, I can't remember the exact number, something like 1 billion. It was expected to be by 2025, like triple that, like 3 billion or something of that order. But the uptick from 1 billion to 3 billion was expected to be almost entirely in mobile devices, because in the developing world, most people access the internet through a handheld device. And therefore, people, it's a much wider problem than this, but a lot of people, a lot of technologists are considering exactly that question, Natalie, which is, what do I do if my app is disconnected? So I think there's a lot of general work going into that. And in this case, clearly where the thing needs to communicate backwards and forwards, it feels quite important.
Yeah, it's a fundamental issue, yeah.
Yeah.
Great.
Okay. Anybody got any more questions, wants to add anything?
I've got what might be, seeing as we've got a couple of minutes, what I'm gonna press on James's theory that there's no stupid question. I'll see if maybe I can ask a stupid one. Or a couple. There's one which is, do you have situations or domains where it isn't possible to reach a sort of single optimization point? Almost there isn't a stable single optimization. So like multiple solutions. And I'll tackle another one, which hopefully isn't quite so stupid, maybe, which is, do you work with companies like Codurance? Would, when it comes to the data integration that feeds into your solution, is that where you use sort of partner companies?
Yeah, totally on the second point. And, you know, we that's not our speciality. So we totally partner with companies there. In terms of optimization, you know, the heuristics we use, that they're not giving you the best schedule. They're giving you an approximation of the best schedule. And that's how they shortcut to some extent and give you that performance. If you were going to try and find the best schedule on some of these problems that are very large, you would literally be there for thousands of years. Just there's not, the computing is just ridiculous that needs to be done to do that. So is that right, Panos, or am I barking on the tree?
Yeah. So we have two types of approaches: exact approaches that they will give you for a specific objective function, they will give you the exact solution. But these approaches can only be applied for small problems. For bigger problems, we have heuristics, meta-heuristic approaches that they cannot guarantee that they will give you the optimal solution, but they will give you a high quality solution in a reasonable amount of time. So that's, you are trading optimality for efficiency. Now, if I understand correctly from your answer, from your question, you said if there is only one solution or something like that. So for there can be many local optimal solutions for one objective function. So as we try to search the solution space, we will encounter this local optimal solution, and that's the effort, to try to improve the current solution that we have in our hands. Now, we are not only using one objective, so we have 6 or 7 different criteria to evaluate the solutions that we have in our hands, and we try to evaluate them in a specific hierarchy of these criteria. So maybe someone wants to optimize first utilization of the engineers or something else, so or the distance traveled. So you can configure this hierarchy, and you can instruct the optimization engine to give you the best possible solution that it can find for a specific amount of time, given a specific hierarchy of objectives that you can set. So that's the idea.
Yeah. Okay. We're just about out of time, everybody. So I'd just like to say again, Ben, thank you very much for your time. That's a fascinating subject. And thank you, Panos, for your answers. Thanks for everybody else for contributing.